Now in this video we're going to do a marathon of exercises using arctangent and arcsine. So just remember what are the derivative of x equals tangent y and x equals sine y. That is, what's the derivative of y equals arc tan x and of y equals arc sine x. So it's the same as saying x equals tangent of y and x equals sine of y. So let's do this quickly. We already do this in previous video, but in order to get a refresh and to not think that this is magical thing, let's do it. So here we do implicit differentiation. Derivative of x with respect to x is just 1. Derivative of tangent of y with respect to x is derivative of tangent y is square secant y dy dx. We want to leave alone dy dx, and we have 1 over square cosine y. Now we want to put square cosine y in terms of sine y. So remember the Pythagorean identities of 1 is equal to square sine plus square cosine. So square cosine will be 1 minus square sine of y. But what's sine of y? That's x. So dy in dx is equal to 1 divided by 1 minus x squared. So derivative of tangent of x equals tangent y, or the derivative of arc tangent of x, is 1 over 1 minus x squared. Now, if instead of having arc tangent of x, we have arc tangent of 2x, next the derivative will be exactly here. You remember that here you will put whatever you have here. Instead of x squared, you will put 4x squared. And next you need to multiply this times the derivative of what is inside, because this will be the chain rule. And so times derivative of 2x will be 2. So times 2. So, alright, just have that in mind. So we have the derivative of arctangent x is 1 over 1 minus square x times derivative of x. Alright, it was for tangent. Alright, and we will derive the more details as we do the exercises. And for sine, it's kind of the similar history. We will have derivative of this is 1 equals cosine y. So this is cosine y dy dx. So dy dx is equal to 1 over cosine y. And again, let's put cosine y in terms of sine y. So this will be dy dx is equal to 1 over the square root of 1 minus the square sine of y. And now what's square sine of y? Is square x. So dy dx is 1 over the square root of 1 minus square x. And remember that if we have something inside, we then take the derivative of what is inside. Alright, so now we have a series of exercises, and we will apply this rule. Alright, so let's go together for the first ones. What's the integral of 1 over 1 plus 9x squared? So if you see this, it has the appearance of 1 over 1 plus square x. Square x being, well, actually, let's suppose that here instead of putting x, I put u. So we have derivative of arc tangent y, arc tangent x, arc tangent u in du is equal to 1 over 1 plus u squared. And the derivative of arc sine of u is 1 minus, is the square, in the u, this is 1 over the square root of 1 minus u squared. So we need to find this appearance in the integrals. So the first one is the easiest one. Here we looked at it. It has the appearance of the derivative of tangent x. So that is the derivative of arctangent u. In this case, u is 9x squared. So if u is 9x squared, so what would be the derivative of arctangent of 9x squared? Arc 9x squared. What's the derivative? So it will be 1 over 1 plus, u is, the square root of this is 3x. So 1 divided by 1 plus 9x squared times the derivative of what is inside. The derivative of what is inside will be 3. So let's do u substitution. Let's put this as the integral of 1 over 1 plus square u times 1/3 du, because if you do u substitution being u equals to 3x, you have that du is equal, du in dx is 3, and so du is equal to 3 dx, and so you need to divide by 1/3 here in order to have dx, because dx is equal to 1/3 of du, so 1/3 of du is dx, and u squared is 9x squared. Alright, so now the derivative is, let me put it in some color. This would be 1/3 arc tangent of 3x. That's it. Now, for this one, we need to do an arrangement. The arrangement is called complete the square, and try to put it as this one. So, here we have this. We can put it as the integral of 1 over 5 times x square x minus 10x plus, minus 4x plus 20 dx. We can complete the square. So 5 times x squared minus 4x. Here, in order to complete the square, I will need that here instead of having 20, I have 4. So I will put plus 20 plus 4, because I wanted to have 4, and I will subtract 4 dx. So this is the integral of 1 over 5 times x squared minus 4x plus 4 is the same as x minus 2 squared plus 20 minus 4, so plus 16 dx. So let me take out the 5, and I have 1/5 of the integral of 1 over x minus 2 squared plus 16 dx. Now, this has also the appearance of 1 plus square u, but is not quite, because we have plus 16 instead of 1. So what we will do, we will divide everything by 16. So we need to divide the numerator and denominator. So we will have 1/5 times the integral of 1 over 16 divided by x minus 2 squared divided by 16 plus 1. Now this part I can take it of the integral and will be 1 over 16, let me put it here, will be 1 over 16 times, no, let me leave it like that. So I will have 1/5 times 1 over 16 times the integral of 1 divided by x minus 2 over x minus 2 squared over 16 is the same as x minus 2 over 4, all this square, plus 1 dx. Now this has the appearance of some arctangent of something. Now the arctangent will be of x minus 2 over 4. So it would be arctangent of x minus 2 over 4, x minus 2 over 4. And now let me do some arrangement. What happens if we have the derivative of this? What would this be? This would be 1 over 1 plus this square. So that would be 1 plus 1 plus x minus 2 over 4, all this square, times the derivative of what is inside. The derivative of what is inside is 1/4. And here in our evaluation we have 1/5 times 1 over 16 times this. So if we put this as, instead of having 1 over 16, we have 1 over 4, and we put it like this. We put 1 over 5 times 1 over 4 times the integral of 1 over 4 times 1 minus 1 divided by 1 plus x minus 2 over 4 all square dx. Now all this, what is inside the integral, is the derivative of arctangent of x minus 2 over 4. And so this integral is equal to arctangent of x minus 2 over 4 times 1/5 times 1/4. So all this over 20. Or you can put it as 1/20 of the arctangent of x minus 2